Welcome to Combining Taylor series. So in the previous video, we saw some sort of common Taylor series or Maclaurin series, as well as some useful properties. We will go ahead and use those here. So in our first example, let's find the first three terms of f of x equals e to the x times cosine of x. So note that e to the x is equal to the sum from n equals 0 to infinity of x to the n over n factorial, and cosine of x is equal to the sum from n equals 0 to infinity of -1 raised to the nth power times x raised to the 2n over 2n factorial. So what we get then is that f of x is equal to the sum from n equals 0 to infinity of, I'm going to rewrite this as 1 over n factorial times x to the n, and then multiplied by the sum from n equals 0 to infinity of -1 raised to the n times 1 over 2n factorial times x to the 2n. Now we had a trick for multiplying series. In this particular case, it will likely be easier if we actually just write out the first quite a few terms of the series. So that 1 over n factorial x to the n series would be 1 for the very first term. Then for n equals 1, we just have x. Then we have plus x squared over 2 factorial plus x cubed over 3 factorial, etc. And then we are going to multiply this by our cosine series. For n equals 0, we have 1 over 0 factorial, which is just 1. Then for n equals 1, we subtract off. We would have x squared over 2n factorial will be 2 factorial. For n equals 2, we would have -1 squared, which is a positive 1. Then x to the 2 times 2 would be x to the 4th. And then we have over 4 factorial. And we have minus, etc. So if we just go ahead and kind of multiply these out term by term. Oh, I should have a plus ... on my e to the x. I apologize. So if we multiply these out sort of term by term, we could view this as 1 times 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. So distributing in the 1 and then minus ... And we could distribute in the x, so we would have plus x times 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus ... We could distribute in the x squared term. We would have plus x squared over 2 factorial times 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus ... And then we could multiply in the x cubed term. So we'd have plus x cubed over 3 factorial times 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus ... And then, of course, we would keep going from here. So again, essentially what I've done is I've distributed the 1 to each term. And then we distribute the x to each term, etc. So if we actually go ahead and multiply this out, we have a 1 alone for our constant term. Then for x, we just have a plus x. For x squared, we will have a 1 times x minus x squared over 2 factorial. And then we will have a plus x squared over 2 factorial times 1. Right? So we have plus negative 1 over 2 factorial plus 1 over 2 factorial times x squared. Okay. For x cubed, so that came from the purple, that would of course just go to 0. For x cubed, we would have our 1, the 1 times won't get us there. X times a minus x squared over 2 factorial will get us there, as well as a x cubed over 3 factorial times 1. So this becomes a, we would have a plus negative 1 over 2 factorial. And then plus 1 over 3 factorial times x cubed. And then of course we could just keep going from there. So we have 1 plus x. This is 1/6, the x squared term disappears, so we have plus 0x squared. And then we would have 1/6 minus a half, which would be a minus 1/3. X cubed. And then we continue on from there. So again, color coding, that x cubed term came from my blue squiggly line terms or products. So let's do another example. Let's find a series for f of x equals e to the x squared. So again, note that e to the x is just the sum from n equals 0 to infinity of x to the n over n factorial. So similarly, e to the u should be the sum from n equals 0 to infinity of u to the n over n factorial. So if we set u equals x squared, then we get that e to the x squared is equal to the sum from n equals 0 to infinity of x squared raised to the n over n factorial, otherwise known as the sum from n equals 0 to infinity of x to the 2n over n factorial. And this should converge for all x, since the original e to the u converges for all u. So this is our series for f of x equals e to the x squared.